Okay, so let's get started. Good morning, everyone, to this webinar organized under the Data Europa Academy. So my name is Ima Farfan Velasco, and I will be moderating the session. So as you know, this topic is going to be on Geospatial Trends 2023, Opportunities for data.europa.eu. So this webinar is going to focus on the emerging trends in the geospatial community. We also had a webinar and a report in 2022, and the report is published. So in case you would like to go back and read the results, I highly recommend you to do it because this is going to be a follow-up from last year. So in this webinar, we will have a specific focus on Geo AI, so geospatial artificial intelligence, and because it was also building up from the request and the brainstorming from 2022. And we're going to have here a great geospatial experts, and I will hand over to them very soon. But before that, we're going to remind some rules of the game. Next slide, please, Angie. So as you know, and we wrote down in the chat, this webinar will be recorded. You will receive them via email, but also it will be on the Data Europa Academy published together with the content from last year's. For questions, you can directly use also the Click Meeting chat, but also Angie will have some interactivity with our participants during this hour and a half. So you'll be able to also interact with our speakers via Slido. And please, it's very important for us to improve in the future. So please reserve 3 minutes after this webinar to help us improve and fill up the feedback form. Next slide, please, Angie. Thank you. So yes, so I'm working on the Publications Office of the European Union that manages data.europa.eu. That is the one covering this initiative. And I will hand over to Angie Kugeler from Conterra, who is a project manager in Conterra 52 degrees north, who would introduce us to the rest of the speakers. So Angie, the floor is yours.
Thank you, Inma. Yes, my name is Antje Kugler. I work for Conterra, a company based in Münster, Germany, where we're at right now. And at Conterra, we focus on integrating geo-information into our customers' workflows and IT structures. And for data.europa.eu, we have a joint team with 52 North, that's Simon Jirka, who will probably join me right now, and Ben Grela, who is logged in from some other place. And we have our Geo AI lead from Conterra, Christopher Bridge, who will be introducing Geo AI and explaining some interesting use cases for you. So I'll just move on to the agenda. So this web meeting is basically to discuss with you as the participants which of the emerging trends are worth that we're seeing right now in the geospatial community are worth further activities for data.europa.eu. And as Inma said, this task is conducted every year, so this is our third time. And the idea behind this task is to basically discuss opportunities for data.europa.eu. So now we're doing the welcome and introduction right now. And in a little bit, we'll do warm-up exercise using Slido, where we would like to ask you what current trends regarding geospatial topics come to your mind, what you find is important. And then we'll start with the part on the Geo AI, artificial intelligence for geospatial insights. We then have a Q&A and basically a discussion on the opportunities for data.europa.eu. Then we have a summary and next steps and the closing. So just to mention this, and we'll be using it in the warm-up exercise as well. If you do have questions or comments, it would be good if you could go to Slido and the questions there in the Q&A. And the code for the Slido is Geospatial 2023. So about the goal of this webinar, it's twofold. First, explain a current trend in the geospatial community. And this year we decided on Geo AI. And then gather input on what opportunities for data.europa.eu might arise from this trend, and how data.europa.eu can benefit from and support the new trend. And the reason we picked Geo AI this year is that in the brainstorming session last year, in last year's webinar, Geo AI, or basically AI, artificial intelligence, and Geo AI were the topics that were mentioned right after open data as a very important trend. So we thought this is a good topic to focus on in this year's webinar. So let's just start with a quick introduction to data.europa.eu. That's the European data portal, which is supposed to be a single point of access to open data in Europe. And the strategic objective here is not just to be the single point of access, but also to improve the accessibility and availability of open data across Europe. And to do this, metadata, that's data describing data, so it's data about data, is being used, is being harvested from very many different sources, and is being pulled together in this official portal for the European data. And a total of currently 179 catalogs from 36 countries is being harvested right now. That leads to descriptions of more than 1.5 million data sets. And the data sources, the catalogs, those are both open data catalogs and geocatalogs. Geospatial data contains information on properties or conditions that are linked to a position of the Earth. And the geospatial context will often uncover interesting revelations. Looking at the geospatial context, so basically the where of a phenomenon, will often make data more meaningful. And a lot of data has a location component that's across all thematic domains, such as agriculture, environment, health, population, transport. So in the European data portal, there's no like special section on geospatial data because it's cross-domain. So a way to find geospatial data would be looking at the formats, and you can see a screenshot there with different geospatial formats where you could set a filter to actually find geospatial data. Next slide, please. So what's a trend? We're using a very broad and simple definition here. Trend as a pattern of gradual change in process, a general tendency, basically. And our goal is to spot these opportunities that are relevant to data delivery and discovery in data.europa.eu. And so let's move to the next slide and then to Slido.
Mm-hmm.
So we would ask you to join Slido. You can do that by using the QR code or going to Slido, sli.do, and then start input this Geospatial 2023. And we'll ask you to add some text, what current trends regarding geospatial topics come to mind. And we will this will result in a word cloud. So here we go. So the Geospatial 2023, we can probably ignore. That was uh, the the text used to the hashtag text to log in. Yeah, we see all these different trends coming in. GIS has been mentioned a few times. Cloud native, cartography, data spaces, digital twins. Yeah, digital twins is a very big topic in the geospatial, well, not just the geospatial community, but any community, but in the geospatial domain, it's been there's been lots of digital twins being set up. Spatial analysis, disaster risk management, open data, drone data, OGC API. So we have some technical mentions here as well, vector tiles, satellite images, link data, remote sensing, interoperability, very important topic to be addressed. Climate data, more machine learning. So we do have some AI topics here as well. Okay, great. Probably leave there's still people typing, and I would invite you to keep doing that. But let's move on with the presentation. We'll probably have a quick look at this before we go to the Q&A. So you're welcome to keep typing here. So we'll start talking about the GeoAI itself, first with a quick introduction to GeoAI, and then examples of using GeoAI. And I'll hand over to Chris here.
Thank you. So yeah, well, let me start with the introduction. So please go to the next slide. So what is GeoAI? How do we define it? We define GeoAI, so geospatial artificial intelligence, as a machine learning technology which enables us to capture and analyze quite complex patterns and structures in geospatial data. Mainly geospatial data. Of course, we use other data as well if it serves the process and the project. So next to the next slide. As most AI projects, GeoAI projects as well, are mainly consisting of data pre-processing. So the whole data part, meaning researching data, analyzing the data, putting it into other formats, transforming it, migrating it. All this is a huge part of any AI project and is GeoAI project as well. And as many of you probably know, the aspect of working with geospatial data needs special knowledge, it needs a special caring. That's why we use the term GeoAI for these things. That's not that we use fancy other algorithms that you normally use in AI. It's mainly this focus on geospatial data. And talking about this data, you can go to the next slide. I can show you a project where we had most of the workings done to the data. So if you go to the next slide, please. The project is called KinoPro, which is an abbreviation of the German title. Oh, back to the slide before, please. And it's an abbreviation of the German title Künstliche Intelligenz zur Nonnenfalterprognose, which is already the shortened title. So the other one is even more German and even longer. So it means artificial intelligence to predict the black arches moth. It's a certain moth that eats away the spruce tree needles and kills off a lot of these spruce trees in German forests. And we had this as a research project together with the University of Dresden, the Technical University of Dresden and Conterra, and we received the data from the state forestries of Brandenburg and Saxony. And it was funded by the Federal Ministry of Food and Agriculture. So the problem we face in this project is that due to climate change influences, the trees are struggling with hot and dry weather. And even more terrible, these forest pests like the black arches moths or the bark beetle and any of these organisms, they adapt quite faster to this hot and dry weather, and they adapt in quite the critical way. For example, they adapt in this way that they sense the struggles in the trees and in the forest, so they reproduce more often and more frequently, and therefore there are even more of these forest pests. So we have irregular popular growth that we don't know before, and high appearances, which is even worse for the trees. And we have forestry personnel who has to care for this, but they are thinly spread. So we have to manage them even more efficiently without having the old uh, geostatistical methods to analyze this data. So we need new prediction models in this case. So please to the next slide. The where I show you how the project is built up. So yes, so we start with the monitoring of the black arches. They are caught in certain traps with a pheromone supplement in it. So you mainly catch the male black arches. So does not really work that you get these creatures away from your forest. It's just an helpful method to see how many are there and to have an estimate of how many of those are there. We put this into FME, where we do the data preparation and pre-processing together with a lot of influencing factors, mainly weather factors, to build up a GeoAI model from this. We use this in a web application to give to the forestries, which can then use it again to clarify if we correctly predicted the numbers, and if not, we can validate it and survey for new parameters. And we did all this and ended up with quite the interesting model. And if you could go to the next slide, please. So we used different parameters. We used rainfall, air temperature, humidity, wind speed, the depth of frost in the soil moisture, and the soil temperature, and the sum of last year's black arches, meaning all the ones that are caught from one certain trap situation. And we use this to predict how many moths there will be in the current year. We also added additional information like land cover classification, altitude, the slope where the trap is built up, and the trap alignment to ensure that we have as much information as possible per trap, per point we are using. So to the next slide, please. The model that was the output of this allowed us to have the possibility to 4 weeks prior to moth activities, meaning the moment these creatures crawl out of the cocoons and start flying around and eating away the needles of the spruce trees. From this moment, 4 weeks prior to that, up to June 15th to August 16th, the main time where these moths fly around and destroy the forest, we can already predict at which places it will be critical, it will be problematic, so we can ensure that the forestry personnel get sent to the exact places where they need to be and don't do too much or too little to preserve our forests. So this was a great output we had of this AI model. If you jump to the next slide, I'm going to go to another project example about anomaly detection in cellular towers. This was quite an interesting project because you have to imagine that these cellular towers, the data they send, it's quite crucial because, for example, emergency calls, they get directed between these towers. So if there's some mistakes, some errors in the data, you can get with your emergency call directed to a wrong place, to a wrong tower, to a wrong police station, fire station, or whatever. So we have to detect if there are anomalies or some simple errors, mistakes in the data. But the data is quite complex, so it's difficult to achieve this with simple statistical solutions. and it has a huge number of parameters with different scalings. So statistics just don't work at this place. You can get some of the errors, you can put rules upon the system to filter out some mistakes, but you won't see everything that is possible. So our solution was to employ an artificial neural network that detects these anomalies. We have no preset rules, meaning that this artificial intelligence can just look on the data completely freely and find where mistakes may be. And we can even use LSTM layers, meaning long, short-term memory layers that have the possibility to look upon this as like what happened 6 hours ago, what happened 5 hours, 4 hours, 3 hours ago, to see if the mistake that might be seen, the error that might be seen in all this might just be a coincidence of development and might not actually be an error. So if we jump to the next slide, I will talk about how the net works that we use. It's really like simplified down this depiction of the autoencoder we used. But to understand this, how it works, it's best explained if you imagine a picture. Imagine a picture of this rocket on the left. This is the input data that gets into this autoencoder, and then to the bottleneck it gets counted down. So you have a more pixelated picture of it. So it takes away a lot of the parameters to try to understand how simplified it can be. And at the end, it tries again from the simplified picture to create the real picture and sees how well it could recreate this picture. And if it fits, it's good. And if not, then the net has to be trained again or recover, or, well, certain parameters are too important. So this can one time be used to um, to lighten the system, to not have as many parameters as there previously are. But it can also be employed to find these mistakes, because if you go to the next slide, if this autoencoder finds a mistake, then you can be sure that in this process there must be something wrong, and this can be quite complex. What is wrong? But if this trained neural network that is trained to count down and reconstruct this information isn't able to reconstruct it, then you can find quite complex mistakes, quite complex errors in the data. So this allowed us to look through all the data automatically in very high speed to find errors just before they enter the system, so they don't make any troubles with the cellular tower systems. So if you would go to the next slide, I have one final example I wanted to show you before I give over to Simon. Now, directed more into marketing and sales, but which is a lot of interest into these new building areas, because you have to be there quite quickly to do your marketing, to do your sales management for any kind of topic. And this is done with manual research at the moment in most times. So meaning you call the cities, you call the communities if there are new building areas coming up. But this information needs to be there as early as possible, because you have to be there as early as possible. You have to be the first one there to do this. So we thought we could do this quite well with an automated analysis of these areas. And we tried to do this with a GeoAI model, but we had one additional point we had to take in there. We needed to do it on open data to make it as easily accessible and easily affordable as possible. So we used Copernicus Sentinel-2 data for this, and the building footprints we got from OpenNRV, and the digital landscape model also from OpenNRV. And if you go to the next slide, what we came up with was an interaction of two models, which you often end up with actually in AI. It's often you don't just use one model to do everything, but you use an ensemble of two or even more models to do certain parts, because they're really, really focused models. So the first model in this case detected simply if there are potential changes, so simple change detection. It took out the information that it found if there are changes, and the second model was there to analyze the changes and predict if it's changes that are due to building activities or other information. And this other important information you have to take away here is that these models were built upon data from March to May, which is typical building phases, but it also means that we could not employ this model easily on data that is from November or December, because the pictures are just too different. So with this, I want to point out how individualized, how focused such models have to be to work well, and that you often have to retrain them, rebuild them, or build up new ones, and you have your focused use case. And with this one, we were able to detect these in at least from March to May quite quickly and offer alerts and information about upcoming new building areas. So with this information, I'm going to give over to my colleague.
Just one question, just to clarify. There was one question in the Q&A in Slido, and the question is GeoAI or Kinopo, are those products of Conterra, software products?
No, it's not. It's not real software products. It's GeoAI in general is the terminology, is a term used for these geospatial artificial intelligence. It's also other places where you can find this, but what we do there is we offer services in finding use cases with you, analyzing data, finding additional data, making the pre-processing, going to the model POC, making perfecting the model and integrating and supporting this. So this is what's from us behind this GeoAI topic. It's not a product itself, and the Kinopo was a project, so completely project based. And well, the product, the output in the end was the model itself, or the information we receive from the model and can put on a map. So yeah, thank you.
Okay. With that, I would like to go on with the next two projects that we would like to introduce here in the session. But perhaps before I start with the project, just a quick hint to those of you who have trouble following the slides. So it seems that there may be a certain issue with some browsers that there's a flickering in the slides, and it may help to switch to Firefox, or in the chat I've also seen that there was a PDF posted which also contains the slides that may help you if you have trouble seeing all the content here. So then I would like to introduce two projects from the research side as well, which are also making use of GeoAI concepts, GeoAI technologies. And the first of these is the Murray Data project. This is a project which aims at reducing the emission of sea transport or freight by 10% by optimizing the operation of freight ships, optimizing the routes these ships are taking, and so reducing the fuel burn, and as a result, reducing fuel consumption. This is a research project funded by the German Federal Ministry for the Economy. It's quite a broad range of partners which we are cooperating with. And on the next set of slides, I will introduce a bit more what we are doing with this project. So next slide, please. So if you look at the Murray Data project, there are different factors influencing the fuel consumption of a vessel traveling across the ocean, delivering some goods. So this can be, on the one hand, data coming from the ship operation. These can be further data such as the travel plans of the ship, the course of the ship, external factors like weather. It can be also more information like traffic regulations. It can be traffic restrictions, and all further parameters influencing how a ship is best traveling across the ocean. So we have different factors influencing this, and these create basically a broad set of data that we need to consider when we are trying to optimize the operation of such a ship. On the next slide, please. You see that there are quite a set of different ways and data sources that we are consuming here. So for example, we are looking at different types of data. So for example, the trajectories of the ships, which are quite important for us. Then vector data, also considering current ship positions, also tabular data from the operation status of the ship, and then also external geospatial data sources, like, for example, Earth observation data. There are very important products that we can use here, vector data, base maps, shipping maps, and finally also then tabular data coming from the ship operation, ship geometry, etc. And for integrating all these different data sets, we are using, or we are trying to use here, standard data formats. So you may know many of these formats from the European Data Portal, for example, JSON, GeoJSON, XML formats, NetCDF. And on the other hand, there are also different ways how these data sets are provided. Of course, the API-based access is very convenient for integrating data here in such a project, but also other types of simple data delivery, file-based data delivery is something we need to consider because the data is really critical for this project. Next slide, please. So based on all these different data sets, which are potentially relevant for optimizing the transportation of goods across the ocean, the first step that we did was some kind of preparation of pre-analysis in order to identify those factors which are really critical for optimizing the ship operation. And for that purpose, we intersected the AIS data with environmental condition information. You see here on the right-hand side some of these. And the result of this was that we were able to generate a set of parameters and factors that we had to consider for building our core model for doing the routing optimization and doing the calculation, which we want to get as core out of our project. Next slide, please. And here we come then to the part which is really related to the AI part. So a lot of work, like typically, like also Chris has introduced, is on optimizing or preparing the data that needs to be used as an input. And here in the last step then, the aim is to develop different types of routing algorithms. So having AI-based routing algorithms, also comparing this to different conventional algorithms, for example. And in the end, we have to solve here a multi-objective optimization problem. So different criteria that we have are, for example, optimize the travel distance, optimize the velocity. The higher the velocity, the higher the fuel consumption. So give a very good estimate in the end also of the expected fuel consumption, keeping an eye on the schedule of the ships. So for example, ensuring that a certain estimated time of arrival is achieved, or for example, considering also safety constraints. And all of this is considered in the design of these algorithms, in the design of the whole project architecture. And in the end, we are now in the phase basically in the project where we are evaluating the results, and hopefully in the next upcoming months, we will be able also to report on the achievements that have been realized with all these different types of data that were integrated. Next slide, please. So just as a summary for this Maridata project, what I wanted to let you know about this is the data availability is a key factor for the success of the project. And that's also the place where data.europa.eu comes into play, because here we also have a tool for discovering suitable data sets. And this is really critical for the success of such projects, that we get on the one hand, opportunities to discover the data. And then, of course, that's more on the provider side, having standardized data access interfaces, common formats for accessing the data, and then by this facilitating the integration into projects such as Maridata, as we have seen right now. And in the end, as soon as we have this available, the value of the data increases enormously because it becomes usable for answering such big research questions. Next slide, please. Then I would also like to quickly introduce another project, which is called KISTE. KISTE is also a nationally funded project here in Germany, funded by the Ministry for the Environment. And this is happening in a context where the application of artificial intelligence technologies in the field of environmental sciences shall be investigated and explored. And the KISTE project is especially looking at questions regarding the infrastructure, regarding also the management of data for making this available for AI projects. And here we are also, again, working with a quite comprehensive consortium in order to answer these challenges. Also, the KISTE project is in its final phase. Also there, we hope to report some condensed results in the upcoming near future. Next slide, please. So, as I mentioned, the KISTE project has a very strong focus on the infrastructure aspects of GeoAI. So that means enabling the access of data across different data providers. So interoperability is a very big topic here. But also supporting the execution of the developed models in different environments. So from a local computer to cloud environments to even high performance clusters, working in different fields of applications. So you will see a few challenges that we try, or our partners try to address here in the project. And then also further challenges like storing trained models, versioning data and models that have been used here, or building also e-learning platform for domain experts. Next slide, please. So in the KISTE project, some of the use cases I would like to introduce here shortly. It's different aspects related all to environmental sciences. So for example, detecting different wilderness areas, protected areas from Sentinel-2 images. So that's more some kind of image analysis. Another aspect is biogenic emissions, deriving this also from different types of Earth observation data. Hazard prediction, that means, for example, risks such as landslides, helping this to detect risks for such hazards based on different input data and models. Hydrometeorological extremes, that's a very hot topic at the moment, as you see also if you look across Europe. So identifying, for example, heavy rainfall events, better prediction of such events, meteorological extremes, that's also here one of the goals. And then finally, cloud variability, so deriving predictions on this via Meteosat data. Next slide, please. So just a quick look at the final architecture or of the architecture of the project. So we have here basically a very distributed architecture that shall enable some flexibility in order to execute such AI algorithms and models in different environments. There's an abstraction layer. And as you see here, we are integrating different types of technologies in order to integrate the data from different sources. We are using R, Python, and other tools. And in the end, enable the execution of different AI models in different contexts. If you are interested a bit more in these technologies, we would also be happy to follow up with you. And with that, I think I come to an end. Next slide, please. To the end of the introduction of the KISTE project, and we are ready for answering questions that you may have.
Actually, there were some questions about, let's start with the one at the end. What platform do you use for KISTE?
So for the platforms, there are different computing platforms we are looking at. For the details, I would have to follow up with my colleagues who are directly working on the project. Here we indeed want to support from local computers for perhaps executing some prototypes to high performance environments or cloud environments.
Okay, great. So there's a question, have you measured the quality of geospatial data sets? And if yes, how?
So it's a very tough question because the quality is really critical for all of these projects because the quality of the input data directly influences the way how it can be used for answering the research questions that we have. I would say there is not one single formal way yet that we have applied to measure the quality. It's more individual analysis of the potential data sets that we can use in order if they are suited. So I think that's also will be a big part of research for the upcoming years to answer this or perhaps facilitate the determination if data sets are suitable for certain questions. But here, I think also a very big challenge will be on metadata, for example, providing the good descriptions of the data sets in order to facilitate this assessment.
Yeah. I think this might also be a question for data.europa.eu. In general, we don't measure the quality of the data or the geospatial data itself. What we do measure, or what we do try to evaluate, is the quality of metadata. And there's a quality measurement tool called the MQA tool, which helps in this case. Okay, now we are having a problem looking at the
but I can maybe
answers.
share a takeaway.
Yeah.
I was yesterday, from Tuesday until yesterday, there was the peak of data integration in Bonn, and one takeaway we also had in discussions about GeoAI and the data used is this problem of having the knowledge of quickly assessing if data has the needed quality or not. And the main problem we face is that this differs from every data format we are using. If you, for example, take 3D LiDAR points, you have aspects like how much was clipped to make it a smaller data set to put on the open data platforms, but you don't have this information needed for any other data format. So this is very complex process right now, but we're actually on it. So.
Okay. So here's a question. Could you elaborate, not on data quality, please, which info metadata on quality is important for you?
Mm-hmm. So also this depends a bit on the specific project context, but in general, what is always helpful is to get information about completeness of the data set, then the resolution from a temporal and geometric point of view, then perhaps also information on methods how data was collected. Is it somehow automatically derived from some other input data? Is there a certain human involvement in the creation of the data set? So understanding really how the data set was created, that's important. And I think these would be some very important aspects that come to mind at first for me. I'm not sure if you have further.
No, it's exactly the same.
And I would actually like to start the poll now. And I know there's still quite a few questions in the Slido and possibly also in the chat, but I think we'll write the answers down and somehow let you get to that information. So one thing we'd like to hear from you is what opportunities for data.europa.eu might arise from this trend, and how can data.europa benefit from and support GeoAI? Okay, so there's a very clear statement there, none, but I'm pretty sure some other participants might have different opinions, or maybe the same opinion as well. So we would like to gather your input here. Standardization, better data quality. Yeah, data quality is actually one of the main. We already got some questions on that. White papers, yes, that could be providing white papers. Linked data, I got your quick guidelines. Data quality, metadata quality. Yeah, quality seems to be the main concern here.
Indeed, and it also relates to each other. So we see here metadata quality guidelines, white paper papers. I think one output or one guidance could be really also in the direction of providing help to data providers, for example, in order to let them know what is important if you would like to share a data set in order to make it really usable for GeoAI applications. So this may be also a combination of all these different types of aspects.
Yeah, GeoAI can help in detection of faulty data.
Yeah, I think that's an important part. I mean, it is important to have high quality data to do high quality AI, but AI can actually also help to support high quality in data with these autoencoder stuff, with detecting anomalies and with enhancing the data quality in general.
Smart applications for citizens. Smart environmental. applications, I guess.
I think that's a very nice idea here, supporting GeoAI by organizing some kind of hackathons. I think that's also very good for involving the community better here in the process.
So there's a question, do you plan to add geospatial metadata to the list of metadata available in data.europa.eu? It will help to properly describe the data sets. Geospatial metadata is actually being harvested right now. So what we do is we harvest metadata from geospatial catalogs via the CSW interface, and we map it to GeoDCAT AP, which is used in data.europa.eu. The thing that you might be referring to is that not all metadata that we're used to in the geospatial world is actually being shown in data.europa.eu in the details, because it's only a subset, the DCAT AP or GeoDCAT AP subset that's being displayed. Okay, let's have a look. There's quite a few things in our sharing use case for inspiration.
I think that's also perhaps sharing some success stories. That could be a very good thing in order to show people what is possible with this technology. And what I also see is standardization, interoperability was mentioned several times now. I think that will also be a key to further support these ways how to share data in an easily reusable way. So that's not only relevant for GeoAI, but in general also one big topic we are trying to promote with data.europa.eu.
Here's one question we can probably still answer. The question is whether GeoAI models have been applied outside of Germany in other EU satellite images, for example.
Definitely. Also the projects I've been talking about. So basically, if we are talking about shipping, optimizing the transportation, we are looking on a much broader scale. So we are looking at this with some partners here from Germany, but the aim is basically to look on a global scale for optimizing this. So definitely. And if you also look at applications beyond what we have shown today, there's a lot of work going on all over Europe in order to use these data, especially satellite images.
Okay, great. I think we should move back to the presentation and to wrap up the session. Thank you so much for all your input and your questions. I must apologize that we couldn't answer all questions, but we'll find a way to get the answers to you. So this was really good to also find here ideas on the opportunities that might arise or things that we might look into to support GeoAI with the offerings of data.europa.eu. So there will be the next step will be that we're going to write a short report. On the slide, there's the link to last year's report, and the findings, also your input in this webinar, will provide further input for the further development of data.europa.eu. So thank you very much, and we'll hand back over to Imna.
Yes, thank you everyone for this great contribution. I have to say that you myself I learned a lot about these projects, and I very much look forward to this future report. So you can stay tuned about our upcoming 2023 activities that are coming up before the end of the year. So the first one would be one webinar that will take place next week. It will be a follow-up from the series on data spaces. So we will invite the health data space and the cultural heritage data space to explain best practices, where they are, and also what's the reason behind and benefits from these data spaces. And they will be followed by a webinar on the 29th of September on the Open Data Maturity Assessment. So we will dive deeper into the policy dimension, um, inviting some member states, some countries to speak about how they're advancing on the implementation of policies. Anyway, as you know, you can get updated about what's happening on data.europa.eu because there are so many activities going on and more to come in 2024. So we strongly suggest you to register to our newsletter, but also follow us in our social media that you can find here. And before you leave, please fill up the feedback form to see how we can improve further. We hope you had a good time and you learned from it. And I wish you a very good weekend ahead. Thank you.